Hello, my name is Baekyu Kim, and I'm an assistant professor at Dgist. I'm leading high assurance software systems lab, and I will briefly introduce our very interesting research areas. Software plays a much bigger role than ever in many applications, including automotive, medical, avionic, and smart cities, and so on. Being integrated with AI, connectivity, and autonomy, modern software is becoming more complex, and this makes the software very complex to build correctly. So increasing numbers of accidents have been occurring due to software malfunction or performance issues. This kind of software quality assurance issue must be the fundamental problem that we have to solve to move forward for the future technology. High Assurance Software Systems Lab is established to tackle key research problems to build reliable software systems. Firstly, when one implements software, we need to be able to say if it is correct or not. This kind of checking can be automatically done by systematic modeling, verification, and validation techniques, which would give us a great confidence of the software that we are building. Secondly, once we model the behavior of the software, we can automatically generate the source code from the model. This is called code generation techniques that remove any programmer errors and reducing coding time significantly. Lastly, once the software is built, it cannot run by itself. That is, the software must be integrated with an appropriate target platform, either hardware platforms or other software infrastructures. If this kind of integration is not performed correctly, we cannot guarantee the assurance of the whole system. So we study how this kind of integration steps can be performed automatically. Let me introduce two ongoing projects that we are currently doing in our lab. Autonomy is the key technology that is widely used these days, such as autonomous cars, drones, or robots. In order to guarantee the safety of autonomous systems, we need to test how it works in many different complex scenarios. However, testing autonomous system in the physical environment has a lot of limitations due to safety, scalability, and government regulatory issues. For this reason, we are studying how to integrate the software into the virtual environment using game engines such as Unity or Unreal engines, where we can test out the correctness of software under diverse risky scenarios. Especially, we are interested in how to define test criteria and how to automatically generate virtual scenarios to improve the confidence of the autonomous software systems. Software is becoming connected to external systems by exchanging huge amount of data in a complex fashion. For example, augmented reality systems can send image information to local cloud infrastructure to precisely detect objects, while overcoming the limitation of the compute resources of AR devices. Or connected cars can send a huge amount of sensor data to the remote cloud infrastructures to enable advanced mobility services. Guaranteeing the performance of the connected software is a challenging problem since there are many diverse factors intertwined together affecting the quality of services such as latency, availability, scalability, security, and so on. For this reason, we are studying how such computation needs to be intelligently performed in the distributed computing context, including computation modeling, compute resource management, and fault-tolerant systems. I explained several sample research areas, and there are a lot more interesting works as well. In addition, I always welcome new interesting research ideas, so let's work on new software assurance related topics together at High Assurance Software Systems Labs. Thanks for listening to our lab introduction, and feel free to contact me for further information.